This video clip will show you how to analyze two-dimensional motion using vectors. So let's say Caleb rides his bike off a jump at 15 meters per second. So he's headed 15 meters per second up the ramp. The ramp is at 22 degrees with the ground. How far will he go? Well, let's break that into vectors for horizontal and vertical motion first, and then it's a doable problem. So if we wanted to know how fast he's going in the upward direction, well, we know that the sine of, what should we call that? Okay, so the sine of 22 degrees equals the length of the side opposite over the hypotenuse. So to solve for u, the upward direction, we'll multiply each side by 15. So the upward direction is 15 times the sine of 22. So 15 times the sine of 22. So in the upward direction, the bike is going 5.6 meters per second. Let's check out the horizontal direction. So we need to find, well, if we want to keep using sine anyways, let's find the other angle. To add up to 90, that one would have to be 68 degrees. So we know that the sine of 68 degrees is equal to the length of the side opposite over the hypotenuse. Solving for h, we multiply both sides by 15. H equals 15 times the sine of 68. 15 times the sine of 68 says 13.9. So he's going this direction at 13.9 meters per second forward. Well, that makes sense. 22 degrees is a fairly small angle. So it's going mostly forward, slightly upward. So I've broken his 15 meters per second at 22 degrees into 5.6 meters per second straight up and 13.9 degrees straight forward. So we're breaking this into vectors. Now we can analyze it because gravity accelerates things down at a rate of 10 meters per second every second. So to find out how long it would take for gravity to reverse the motion upwards, we could just see how long that would take at a rate of 10 meters per second. So our 5.6 meters per second divided by 10 meters per second every second gives us 5.6, oops, 5.6 divided by 13.9. No, sorry, 10 divided by 10. Shoot. You don't even need a I should not even have used a calculator. 5.6 meters per second divided by 10 is 0.56 seconds. So the bike will be going upward for a little more than half a second. Well, gravity is interesting because it will take that long to get him back down to the same place he was when he left the top of the jump. So I'll go up and down that much time. So if I double that time, that will tell me how much time I was in the air total. Two decimal places, 1.12 seconds in the air. 1.12 seconds times 13.9 meters per second. So all the time that I'm in the air, I'm still going forward at 13.9 meters per second. That's assuming no wind resistance. There is some air resistance, but we'll ignore that for now. Okay, so the seconds in the denominator, seconds in the numerator, all we're left with for units are meters, and that's what we want to know is how far will we go on this jump. 1.12 times 13.9 gives us 15.6. We call it 15.6. So how far will we jump? We will jump 15.6 meters. Fairly tough problem analyzing it without vectors, but with vectors it simplifies it quite a bit. Let's do another one of those problems just to make sure we are following. So we're going up at 14 meters per second at 21 degrees. We know the sine of 21 degrees equals the length of the side opposite over the hypotenuse. Solving. 14 times the sine of 21 is 5 meters per second. So finding the horizontal direction, we need to find the other angle, which is 69. The sine of 69 is equal to the length of the side opposite. We call that the horizontal divided by the hypotenuse. It's 14. Solving. 14 times the sine of 69. 14 times the sine of 69 degrees is 13.1. So we're going forward at 13.1 meters per second. So we need to find out how long we're in the air. 5 divided by 10. It says we're in the air for half a second. Or we're going up for half a second. So up and down would be 1 second. At 13.1 meters per second, that is 13.1 meters. So I'll go 13 meters on that jump.